Hi everyone, welcome back to my channel. Today we are going to dive into the fascinating world of liquid chromatography. This technique is essential for separating, rectifying, and quantifying components in a liquid mixture. Whether you are a student, researcher, or just curious about how scientists analyze mixtures, this video is for you. Let's get started. What is liquid chromatography? In simple terms, liquid chromatography, for short, is a method used to separate different components in a liquid mixture. This technique is widely used in various fields such as pharmaceuticals, environmental testing, food science. For example, in pharmaceuticals, liquid chromatography helps ensure the purity and composition of drugs. Environmental testing is used to detect pollutants in water and soil. Let's move to the another slide. How liquid chromatography works. Now let's talk about how liquid chromatography works. The process involved two main phases, the mobile phase and the stationary phase. Mobile phase, this is the liquid solvent that moves the sample through the column. Think of it as a river carrying a mixture of substances. Stationary phase, this is the solid material packed in the column. Imagine the stationary phase as the riverbed with the rocks and sand that interact with the substances in the river. When we introduce our sample mixture into the mobile phase carries it through the stationary phase in the column. Different components of the mixture moves at different speeds due to their interaction with the stationary phase. This causes the components to separate. Mobile phase. Let's dive deeper into the mobile phase. Mobile phase, a liquid solvent that moves the sample through the column. Common solvents include water, methanol, acid, aceto, acetonitriol, or a combination of these. The choice of solvent is crucial because it affects the separation process. For instance, some solvents may be better at dissolving certain components, leading to better separation. Stationary phase. Stationary phase is a solid material packed inside the column. Common material includes silica, alumina, or polymeric resins. The stationary phase interacts with the components of the sample mixture, affecting their movement through the column. For example, some components might stick to the stationary phase more than others, causing them to move slower and separate from faster moving components. Here are the four steps of chromatography, liquid chromatography. First one is sample injection. The sample mixture is introduced into the mobile phase. Imagine injecting a small amount of dye into the flowing stream. Second one is column separation. The mobile phase carries the sample through the stationary phase in the column. As the sample moves through the different components, separates based on their interaction with the stationary phase. Detection. Separate components are detected as they exit the column. Think of it as different colors of dye appearing at the end of stream. Data analysis. The detected components are analyzed to determine their identity and quantity. This is like measuring how much of color dye is present. Here are types of chromatography. There are three types of chromatography. High performance liquid chromatography. This method uses high pressure to push the mobile phase through the column for faster and more efficient separation. It's like increasing the flow rate of our steam to separate the dyes more quickly. Ultra high pressure liquid chromatography for an advanced version of HPLC with even higher pressure and better resolution. Imagine a supercharged version of HPLC that gives even more precise results. Flash chromatography, a rapid version used for quick separations, often in preparative applications. Think of it as a high-speed steam that separates dyes in a flash. So next slide is application. Liquid chromatography has a wide range of applications. In pharmaceuticals, it is used to analyze the purity and composition of drugs. For instance, LC ensures the pain reliever contains the correct amount of active ingredients and no harmful impurities. Environmental testing. LC helps detect pollutants in water and soil. For example, scientists can use LC to identify and measure pesticide residues in a water sample. Food safety. LC ensures the quality and safety of food products. Imagine using LC to check that a fruit juice contains the right amount of vitamin and no harmful additives. Clinical testing. LC monitors biomarkers and therapeutic drugs on patients. Doctor can use LC to measure the level of a drug in a patient's blood pressure to ensure it is within therapeutic range. Here is the practical life example of LC. Mm, let's go through the practical example. Suppose we want to analyze the amount of vitamin C in an orange juice. First, we will prepare the sample. First, we extract the vitamin C from orange juice. Next we introduce the extract into the LC system. Then mobile phase carries the extract through the column, separate vitamin C from the other components. And the last step is detection. As vitamin C exits the column, it is detected and quantified. The process helps ensure the orange juice contains the correct amount of vitamin C as labeled. To sum it up, liquid chromatography is a powerful technique for separating and analyzing components in a liquid mixture. It involves mobile phase that moves the sample and stationary phase that helps ensure the separate the components with various types like HPLC, UHPLC, and flash chromatography. This technique has numerous applications in a different fields. Thank you for watching. I hope you find this explanation of liquid chromatography helpful, interesting. If you have any questions, feel free to leave them in the comment sections. Don't forget to like, share, and subscribe for more videos on scientific techniques and experiments. See you the next time. Bye bye.